Hello everybody, this year TryHackMe again created their own advent calendar for this year's holiday season. It is once again aimed at beginners, but I guess everyone can learn a few things from it here and there. So without further ado, my name is Avocari. It's time to get festive and crack open the 11th window of the TryHackMe Advent of Cyber 2022. Not all gifts are nice. So, today we're going to be tackling memory forensics. The elves in Center Security Operations Center, SSOC, are hard at work checking their monitoring dashboards, where Elf McDave, one of the workshop employees, knocks on the door. The elf says, "I've just clicked on something and now my workstation is behaving in all kind of weird ways. Can you take a look?" Elf McKitty tasks you, Elf McBlue, to investigate the workstation. Running down the workshop floor, you see the computer prompt running some code. Uh-oh, this is not good. You immediately create a memory dump of the workstation and place this dump onto your employee-issued USB stick, returning to the SSOC for further analysis. You plug the USB into your workstation and begin your investigation. So, while I start the machine, we're gonna talk about the memory forensics part. So, what is actually memory forensics? Memory forensics is the analysis of the volatile memory that is in use when a computer is powered on. Computers use dedicated storage devices. They're called RAM or random access memory, which remember what is being performed on the computer at the time. So the RAM is pretty quick, and the preferred method is storing an SS data. So there is limited storage on other devices. It is limited to storage devices such as hard drives. So this type of data is volatile because it is deleted when the power is off. So the RAM stores data, for instance, the clipboard or unsaved files. We can analyze now the memory to see which processes are running, which network connections were being made, and other useful information. So let's think about cooking. So the example that they bring here is a pretty good one. You normally store all your foods in a fridge. A hard drive is not a fridge, so we have everything stored on the hard drive. So when we're cooking, we will store ingredients on a kitchen counter so that we can quickly access them. So this would be our random access memory, which is much smaller than the fridge. So why is memory forensics not useful? Memory forensics is an important element to investigate a computer. You can make a memory dump and then analyze it, and nothing can hide from memory. So you can hide network connections and other stuff in the background so that it is not visible. And also malicious code hides from the users, but it cannot hide from the memory. It still will need it to be executed there. So we can capture the memory for analysis at a later date, and all data might be lost at some point. So when the computer, for instance, is powered off. So when we save it, we can still discover what malware was doing even after the computer was powered down. So the easiest ways is you can see the process in a task manager on Windows, or top or htop or something else on Linux. We have two categories. We have user processes and background processes. The user process would be, for instance, the notepad.exe that was started, and the dmw.exe file is an essential process for Windows for displaying windows and applications on the computer. That would then be a background process, which are automatically launched. For inspection of memory analysis, we use volatility. This is an open source toolkit for memory forensics. You can check it out on GitHub. Download it from there, follow the requirements and the instructions to download and install it. We can list processes, for instance. We can find out what is actually running on the memory dump and so on. So I'm gonna go over that while we're actually doing the analysis of the image. So again, first of all, let's see what they actually want us to do here. First of all, what is the version number? Make the initial scan. Okay, volatility and memory framework is located in home elf McBlue volatility free. Okay, so our machine is not showing up, so I guess we have to go to the top and show the split screen of it. I'm gonna go again and open it up in a separate window. Let's exit split screen again and go back down here. Okay, so whoops, ls volatility. There we have our volatility. And where do we actually have the memory file? This is workstation.vmem. So we make an initial scan. This is the first part. For the initial scan, we use tag F. So that way we can actually make the start of everything. So we say python 3 vol.py tag F with our workstation .vmem file. So this might take some time. I'm gonna fast forward. Oh, select the plugin to run. What do we actually want to run at the beginning? We probably want to find out the image info. So anything about the image. This is easy one. Error argument plugin invalid choice image info. What was it called? Image info. Windows.info, right? Because we're on Windows. Windows.info. Windows.info. So this now takes time. And I'm gonna fast forward until it is completed. Okay, so the final results are in. We have the kernel base, we have the name, Windows Intel 32E. The major version is 15. NT major version is 10. Operating system is also 10, so I think this is Windows 10 then. Let's see. Wait, what? Windows version number was captured. 10. What is the name of the binary gift? That's Secret Santa left. We need the ps.list, or how Windows ps list, how it's called. We go windows.ps list. It should be a lot faster. So we want to just quickly dump out the processes which were running at the time. Maybe we can find something from there. There we go. Okay, that's a lot more. And here we have mysterygift.ex. Oh, I don't know, is there something else interesting inside of it? CRSS? No. SVC hosts are also not interesting to us. So I guess the mystery gift dot x mystery gift dot x is the one we're looking for. Mystery gift dot exe. What is the process ID of this binary? The process ID, is it the first or no, the first one. First one's the PID. So 2040. And now we need to dump the contents of the binary. How many files are dumped? We can say dump files for a process ID. So we go here, dump files for the process ID of 2040. That should be pretty straightforward. You can also, I think you can also specify a folder where you could dump them inside of. I'm curious now what happens. Maybe it just tells me that right here. Okay. We're not outputting them, probably just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Looks good. I guess it's 16 then, right? So 16. Nice. So now the next tasks that I would do after that is actually dumping them out to my computer, looking through them, maybe uploading them again to VirusTotal like we did in one of our malware analysis videos. Or we look through them with strings again, analyze what is inside of the files. But that was a quick room. Compared to the last two rooms, this was actually pretty quick. Feels good to have a lot of easier rooms again right now. So if you want to learn more about volatility, they have a whole room targeted at volatility you could access. And there are also other forensic rooms like the digital forensic and incident response module. We'll learn a lot about those kind of topics. But yeah, that has been it for today's Advent of Cyber, day 11. So tomorrow we're gonna continue with the next day. We have used volatility now, maybe we need to use it in one of the later videos again. But I would guess that this is not the case. Well, I hope you enjoyed today's video. Please make sure to subscribe and turn on the notification bell in order to be notified when the next video is uploaded. Also make sure to like this video if you enjoyed the content that I'm creating. My name is Avocari. This has been the 11th day of the Advent of Cyber 2022. Have fun hacking your way through it yourself, and I'm gonna see you next time. Take care.